Welcome. In this video we are going to discuss about SPECT. What is SPECT? SPECT, Single Photon Emission Computed Tomography. So SPECT is an imaging technology, single photon. So SPECT scanner, it uses single photon for making an image. Unlike PET, which uses the dual annihilation photons for image creation, SPECT uses single photons for image creations. Emission, so it uses emission imaging. For example, in X-rays we are transmitting the X-rays and we are recording the images based on transmission imaging, how the X-rays is observed by the organs, like that. For example, in ultrasound imaging we uses the reflection based imaging. So how much the sound waves is absorbed by the organs and how much it is reflected by the organs. So instead in SPECT we are taking emission imaging. Emission in the sense something is emitted. Okay, let us see what it is. Computed tomography. It uses the algorithms to produce 3D imaging. So SPECT, single photon emission computed tomography. Single photon emission computed tomography is a medical imaging technique that is based on conventional nuclear medicine imaging and tomographic reconstruction methods used frequently in diagnostic medicines. SPECT produces three-dimensional image of distribution of the radioactive tracer injected into the bloodstream and subsequently taken up by certain tissues. This is done with the use of specialized nuclear medicine cameras, that is nothing but a gamma cameras. A small amount of radioactive tracer is injected into the bloodstream. Inside the body, the tracer produces a type of energy called gamma rays. So the radioactive isotopes is used as a radioactive tracer. What the radioactive isotopes will do is it will emit the gamma rays inside the patient body. A gamma camera is used to pick up the signals from the tracer and a computer converts them into the pictures of the blood flow through your heart. For example, if you are injecting a radioactive tracer or radioactive isotopes in order to take the images of the heart. Okay. So what it will do, a gamma camera uses to pick up the signal from the tracer and the computer converts them into the pictures of the blood flow through the heart. Images of thin slices made all the way through the heart can be produced from all different directions and angles. These images are reviewed for the location and the distribution of the tracers, and the computer graphics can be used to create a three-dimensional image of the heart from the thin slices of the images. Nuclear imaging produces images by detecting radiation from different parts of the body after a radioactive tracer material is administered. The images are recorded on a computer or on a film. Different types of nuclear imaging tests have different preparations. The main difference between the nuclear medicine imaging and other radiological tests, for example like X-rays, CTs, MRIs, such that other radiological tests. Nuclear medicine imaging is SPECT, PET scanners, like that. So what is the main difference between those two radiological tests? Nuclear medicine imaging evaluates how organs functions, whereas other imaging methods access the anatomy, how the organs looks. So let us see the SPECT instrumentation systems. What is the basic unit of the SPECT is the gamma camera. So now let us discuss how the gamma camera works, and then we will discuss the SPECT instrumentation systems. So this is the basic of the SPECT instrumentation systems. So usually the gamma camera. So you can look at what are the things involved in this: patient, collimator, sodium iodide, thallium doped crystal, that is NaITI crystal, light guide, PM tube, PM in the sense photo multiplier tube. Then computers, amplifier circuits, computers and monitor. So patient, here we are going to give the radio tracer or radioisotopes to the patient. So after giving the radio tracer to the patient, the radio tracer or the radioisotopes, it will emit the gamma rays. For example, if we want to capture the liver images, we can able to give the radio tracer, or we can inject the radio tracers in the area of the liver. So the tracer will spread over that and it will emit the gamma rays. So the detector will consist of the collimator, crystal, photomultiplier tubes and position localization circuitry. So collimator, crystal, PM tube and position localization circuitry. When a photon of the radiation leaves the patient body, when the photon is emitted, when the radio tracer is given to the patient body, it emits the photon. When the photon of the radiation leaves the patient body, it passes through the collimator and interacts with the crystal, where its energy is converted into light. The light from the crystal is received by the photomultiplier tubes and converted into an electrical signal. This electrical signal is passes through the position localization circuit, whose output consists of X, Y positional signals and Z for the energy signals. The X, Y and Z signals are processed by special correction circuits, which compensates for errors in the detection and the localization of the photon. So what are the different types of radioactive tracers are used? So these are all most commonly used radioactive isotopes while taking the SPECT nuclear medicinal imaging. So the radioisotopes are 99 MTC, that is technetium 99. So the decay mode of this is isometric transition. The energy emission is 140 kilo electron volt. So the half life of the technetium is 6 hours, nearly 6.03 hours. Technetium, thallium, gallium, indium, iodine and xenon. So these are all the different types of radioactive isotopes used for SPECT scanning. So SPECT scanning, the basic is gamma camera. So the SPECT instrumentation system, so here we can look at, it is divided into 3 categories. One is arrays of multiple scintillation detectors, one or more scintillation cameras and hybrid scintillation detectors, combining the first 2 approaches. SPECT system generally uses a single gamma camera mounted on a specialized mechanical gantry that automatically rotates the camera 360 degree around the patient. SPECT system acquires the data in series of multiple projections at increments of 2 or more degrees. Some SPECT systems can also be used multiple cameras. Multiple camera heads are also available. For example, in dual head systems, 2 180-degree opposed camera heads are used, and the acquisition system is reduced by half with no loss in the sensitivity. Similarly, triple head SPECT system can also be used. It improves the further sensitivity, and if we increase the triple head to 4 head cameras, then we can further increase the sensitivity of the SPECT instrumentation. So this is all about a SPECT system. So here the photograph of Philips Brightblue SPECT bar CT system is shown here. So this technology is now routinely integrated with computed tomography to provide SPECT/CT imaging, where the CT information provides reference of framework, that is anatomical information is provided by the CT, and to improve the diagnostic value of the SPECT image data. Thank you.